When the permafrost thaws, the organic matter in the permafrost thaws as well and begins to decay. The microorganisms start to eat it. If there's no oxygen, the microorganisms make methane. If there's oxygen, the microorganisms make carbon dioxide. Permafrost. Right here. Frozen dirt.
We found, as far as the organic matter coming out of this hill slope, is that it's much more bioavailable, meaning it's yummier for the microbes that are decomposing it than carbon or organic matter near the surface today. So that has climate implications, because that means that this organic matter is processed quicker. It's returned to the atmosphere as carbon dioxide and methane and can feed back on climate that way. Sites like this, where the permafrost is releasing organic matter, act as accelerators. They speed up the process of human-caused climate change. And in fact, a recent study showed that the contribution of carbon, of organic matter being released from the permafrost region, might amplify human impacts by up to 30%. So we put out a certain amount of carbon each year, around 10 petagrams, 10 gigatons of carbon each year. The permafrost system may respond by contributing up to 3 gigatons of carbon. So it's a large amplification of what we're doing. It feeds back onto our impacts. It's important to realize that the scale and rate of change that we're talking about now is several degrees, 2 to 5 degrees in just 100 years. So this is much faster than has happened in the last 50 million years. We're talking about unprecedented climate change and a very rapid, abrupt response from this ecosystem.
The reason that we settled on the Arctic is threefold. Number one, all of the models predict that the climate change will happen first in the Arctic. Number two, the climate change is predicted to be largest in the Arctic, especially over land. We're talking about forecasts where the surface land temperature might change by up to 10 degrees centigrade, which is approximately 18 degrees Fahrenheit over the next century. That's much, much different than what people talk about for global average surface temperature change. Number three, because the Arctic is relatively remote, has little influence from human activity, it's a very pristine or clean environment, and it would have very, very high sensitivity to any of these changes. So it's very much like the canary in the coal mine. If you're likely to see anything related to climate change, it will happen in the Arctic. If someone asked me if the climate system were changing, I would say, look at the data. In the last 10 years, we have had 7 or 8 of the hottest years since we began keeping records with thermometer measurements. There have been changes in the Arctic, in the permafrost, in terms of the temperature over time, not only in the shallow layers near the surface, but at 10, 20, and 50-meter depths, you're seeing changes that are even more rapid. That indicates that not only is there heating near the surface, but that this heat is being transported to depth very efficiently. I would also say to look at the changes in the severity and the frequency with which we have major storms, typhoons, and hurricanes. All of these things are what the models tell us, at least qualitatively, will happen as the Earth's climate system goes from the relatively stable conditions that it has been occupying for the last several centuries and begins to transform into a new state. These uncertainties, these large swings in temperature, in storm severity, etc., are exactly what we would expect to see. So everything that we're observing is consistent with what the models tell us should be happening.